All right, welcome everyone, and welcome to the FlowForge monthly webinar. Today, we've got our webinar about the FlowForge device management solutions on really how to deploy Node-RED out to hundreds of PLCs or IoT edge computers. My name's Ian Scarrett. I'm the head of marketing at FlowForge. I'm going to be your host today. Rob Marcer is going to be the important person. He's going to be the speaker. Before we get going, Rob, could you just go to the next slide for me? Just a couple of housekeeping notes. I always like for people to, if you're interested, please take time to introduce yourself in the chat pod. It's always great to see where people are joining us from. We usually get a very international crowd, so it's always nice to see that. The session will be recorded. So we often will get questions will the session be recorded? Yes, the session will be recorded. We will send a link to everyone after the webinar. It usually takes around 24 hours to get it all up on YouTube, but we will get it done. Final thing is that we always encourage questions, but please ask them in the Q&A pod at the bottom. Please don't ask them in the chat because it's really hard to track them in the chat. So ask your questions in the Q&A pod. There's going to be lots of time available at the end for questions. So please get them in. Okay. Without further ado, I'd like to welcome Rob. Rob, how are you doing today?
Hi there. Yeah, I'm doing great. Hello. How about you? You good?
Good. Yeah, absolutely. I'm really looking forward to this. So let's get going. Take care.
Thank you. Hi, everyone. Thank you for joining us today. So before I get started, just a little bit about me to set the scene. So my name is Rob Marcer. I'm the Customer Success Manager at FlowForge. So a little bit of background about how I ended up being involved in the Node-RED community. So I first discovered Node-RED during the COVID-19 pandemic. I used that. Certainly in the UK, we had a lot of time where we all stuck at home. So I decided to learn how to use Node-RED to automate all the things in my house, which kept me from going crazy during that time being stuck away from work. Happily, when we all managed to get back to work, I took the skills that I'd learned back to my day job, and I was working for a customer relationship management company. So what I then did is implemented all the tools necessary for that company to use Node-RED in a production environment. So the infrastructure, the hosting, the DevOps. So for instance, we could, as a team, collaborate on building and working on Node-RED instances. What we used that to do was, as I said, I was working for a CRM company, customer relationship management. We used Node-RED to link that database of people to lots of other systems that they might interact with. And this was for restaurant and hotel companies. So might be linking a booking platform into gift card or feedback system. So using Node-RED to pull all of that data together to give our customers a really good view of who their customers are. I joined FlowForge, I think it's just nearly a year ago now, a few days off that. I'd been looking at FlowForge as a potential supplier for the company I was previously working for, because we're looking for better and better ways to host Node-RED and to manage working on different builds of applications. So I'd already had my eye on FlowForge, and then when a job came up, I was immediately applied and very, very happy to be able to join the team. I think Node-RED is fantastic. I think it's empowering for people, and happy to spread that word about how Node-RED can be used. I'd be good if I knew how to go on to the next slide. Right, okay, I've now worked that out. So today we're mostly focusing on things which is perhaps more relevant to an industrial setting. And Node-RED is used in lots of places in industry. I just keep on seeing more and more when dealing with customers, different ways in which they're using Node-RED and primarily it's to extract data from all of their systems. So yeah, looking at the examples, these slides that we've got here, or these images. So Node-RED might be used to extract data from, so say, energy production for, and I call these things windmills. It's not the correct word, wind turbines. So for instance, you might be wanting to extract information on energy production, or maybe things such as vibration in those sorts of scenario, which might indicate hardware is failing. You might want to be monitoring robots on a production line. So yeah, like their various performance characteristics. Then you've got, yeah, like an example of a car production line. And the last one, which I feel is a picture of a poo processing plant, I think. I think Ian put this slide in. So yeah, but I mean, jokes aside, as much as it's a funny image to include, yeah, it's another scenario where potentially you've got lots of machines distributed out and you're wanting to track their data from those machines, and Node-RED makes that a lot easier. The way in which this is usually done is you would be using PLCs or Internet of Things edge computers. So PLCs, piece of hardware, and sorry, I know for lots of you know exactly what I'm talking about, but wanting to include everyone. So PLCs are computer systems that would sit near to equipment, so perhaps on a factory floor, to collect information from those pieces of equipment and potentially also control them. Traditionally, PLCs were quite often quite simple devices with not a whole load of compute power. What we're now seeing, though, is more and more of the newer PLCs that are coming out actually have more significant compute power, and they can actually run an operating system on them, and that allows you to run Node-RED directly next to those devices. Where that's not practical, what we're also seeing is deployment of devices which can run full computer operating systems, so such as Raspberry Pis or all different flavors of Pis, next to more legacy PLC equipment, so that they can extract data from those PLCs and then use Node-RED to pass that on to where it needs to be. So why is Node-RED really good for extracting data from PLCs? And that was a tongue twister, apparently. So Node-RED is really good because it's really easy to quickly build a flow to extract data from systems. It's quick and easy to learn. You don't need to understand a particular programming syntax or language. You can pick it up quickly and code or build new flows to extract data from hardware. And yeah, it's just very easy with a visual representation of the systems you're building. There is a huge library of custom nodes. So those of you who are using Node-RED, you're probably used to dragging in certain elements from the sidebar that deliver certain bits of functionality. It might be to make an API call or to put something into debug. So, but those ones that people tend to use initially are the ones that come built into Node-RED, but there are thousands, tens of thousands, I think I'm right in saying, of nodes which have been generated by third parties, both companies and individuals. What they make it really easy to do is to extract data from and push data into lots of other systems. So there are off the peg things that can deal with most databases, that can deal with various communication protocols, say MQTT, or things which are used in a manufacturing environment, things such as, say, Modbus. So quite often, if you want to interact with a certain piece of hardware or a certain service, someone will already have written something that will help you do that, so you can spend your time writing your flows and using the data rather than working out exactly how to extract data from a legacy system and get it into a usable format. The last point would just be that what's great, another thing that's great about Node-RED is it's open source, so it's completely free to use. You can view all of the source code. You can, if you wish, and some organizations, individuals are doing this, you can actually get involved in the development of Node-RED. So you can actually see what's going on underneath. And if you can see something that's of value to a particular project, you can write that code into Node-RED, and assuming it's something that's roughly beneficial for the general community, there's a good chance that that will actually end up in the main build. So anyone can use it for free, and anyone has the ability to understand how it works and contribute to the code base. So Node-RED is great for extracting data from one PLC. And for the rest of this, I'm not going to keep saying, I'm going to try to not say PLC or IoT. I'm just going to refer to them as PLCs, be that a PLC that can run Node-RED itself or a PLC that's associated with another device that's actually running Node-RED. So Node-RED is great for running on one PLC for the points we just covered, but it can be quite hard to manage it when you're dealing with a significant amount of PLCs. So the sorts of things that can be challenging is if you need to update your flows that are running on a significant quantity of PLCs, that can be quite a labor-intensive process. If you want to update Node-RED, so never mind actually updating your own flows, but what if you need to change the version of Node-RED you're running? How might you go about managing that on all of those devices? And then also finally, it can be challenging if you know that machine number 23, there is a problem with it. It can be sometimes challenging to actually connect to the Node-RED instance running on that machine and interact with it to try and work out what's going on. I've seen some quite good solutions to those to that last point, but it can always be a bit of a pain, especially maybe if the engineers that are working on the flows, and I often see this when working with customers, maybe in a different city or potentially on a different continent to the devices that they're interacting with. So what's the answer to that problem? The answer is FlowForge. So FlowForge makes it really easy to manage your instances of Node-RED running on your PLCs on your factory floors or wherever your machinery is that you want to interact with. It provides the tools to manage your different builds of applications. It provides the tools to update different versions of Node-RED and manage that, or like some of the underlying components of Node-RED, such as NPM. It makes it really easy to connect into and it's one of the main things I'm going to demonstrate today, to connect into your devices running on your factory floors, interact with them, change the flow that you've written, test that, and then deploy that to the rest of your devices. So FlowForge is very much making Node-RED into a much more practical tool to use when you are dealing with more than one device in your application. Okay, right. So that's the introduction. I'm now going to get to a demo. So let's just go through my notes, and I need to drop out of, I need to work out how to use this. Exit full screen. Okay, great. Okay. Right. Okay, got to where I need to be. So today I'm going to be demonstrating how to manage a large fleet of PLC devices. We're also going to be looking how to monitor those devices, spot downtime, collate telemetry from the devices, or normally that would be from the machines which they are near to, and the process of managing your Node-RED flows and making updates. To do that, I've got a couple of components that I'm going to use. So I've got a Node-RED flow that I'm going to deploy to PLCs, and then I've got a central management system which we're going to use to monitor what's going on with those devices as we're making changes to them. I'm going to simulate the PLCs today. I'm going to do that because I don't have enough PLCs at home to run this on actual hardware. I think my wife's quite happy that I don't have enough PLCs at home to actually run this. So I'm simulating the PLCs using a software called Docker. They are all going to be running on this laptop over here. You don't need to be able to read what's going on that screen, but basically all of the devices we're going to be interacting with are actually being created on here as needed. The first thing I'm going to do is I'm going to start the process of creating. So I'm going to create 50 PLC devices, and then we're going to look at how we can manage those devices. So I'm going to do that live while I'm talking, because I really like to cause myself stress. So the first thing is you can actually, so I've created a dashboard, which at the moment is very blank. It looks like this, but this is where we're all going to be able to manage. So I monitor what's going on with these PLCs. So Ian, if you could possibly drop the link into, I suppose I can do it if 1 second. Ian may have already done it in all fairness, but I will Thanks, Ian. Thanks. That's great. So if everyone jumps on there, you should all be able to access it fine. It's open to the internet. Please let me know if you have any problems with that, but that should all work fine. Please don't denial of services. For those of you who know how to do that, I really like when we're doing these webinars to allow people to interact with the things we're building. A bit of a risk is potentially it opens up to things going wrong with the presentation, but yeah, I mean, please, hopefully you will be able to see that helps you follow along a little bit better what's going on. So the next thing I'm going to do is I'm going to start up the creation of our 50 PLC devices, which I can do by pressing this button here. And then I can get rid of that and leave that to do its thing. So what we're going to see, and I'll wait until you start to pop up, is we should start to see the devices appear on this dashboard. No stress at all. I can see they're all coming on this screen here. We're now up to about 5, but there's a little bit of a lag before they show here. But what's going on is the devices are starting up. They are being associated with the FlowForge team that I'm using for this demonstration. So a token is passed to these devices as they're starting up. And that then, allows them to communicate back to FlowForge. So FlowForge can then take over the management of those devices. And thank you for popping up. That was just starting to become stressful. So FlowForge can take over the rest of the management of those devices and the flows on them. So what we're seeing here, and we'll talk about this in a little bit more detail in a bit, is this graph is showing how many devices, how many of our PLC devices are currently online. And this number 1 is which build of our software, of our flows they're currently running. So currently they're running version 1, but we'll change that a bit later. A couple of graphs showing telemetry from the devices, being that these devices, these PLCs, don't actually have access to any hardware. I wanted to show some data being collected. So what I've included is we're pulling the CPU percentage usage and the RAM percentage usage from each one of the PLC devices, just to have some data that's being passed in. So we'll leave this running. Hopefully this will just perfectly go up to 50 devices whilst I start talking about the next bit. So then let's have a look at the flows that we're using a little bit. So I'll just go here first. So as I mentioned, there's 2 flows. There's a central management system and the flow that's running on the PLCs. And this is the flow that's running on the PLCs. It's really simple. I'm not going to, so quite often on these webinars, we might talk about how all of this stuff works. I'm going to keep it top level terms so we can focus on what hopefully is the value here for everyone, which is how we can manage lots of instances, lots of PLCs running Nodeware. So, but basically what this does is every so many seconds, it finds out lots of information about the PLC it's running on. So the name of the PLC, I think it finds the MAC address, it finds the version of the software that's been run, various different things are collected there. It then makes a request to find the current RAM and CPU usage. Now, this would be where you would normally collect data from something like Modbus. Maybe you're collecting data via, on say a Pi, it might be via GPIO or some sort of USB sensors, but this is where you would pull that data. So basically we're finding out about the PLC, we're finding out about the device that it's associated with, and then we're going to send the data out. Now we're sending that data out via MQTT, but it's really easy to do that within FlowForge. What we've built is a wrapper around MQTT, which means that we can link any flow on any instance, be it running on a PLC, on FlowForge Cloud, or any instance that we're managing. It's really easy to link data from one of these. So we have project in and project out nodes, and the data, wherever you then deploy that flow, will just work. So that's where the data flows to. Let's just see how we're going here. Great. We seem to be up to about 17. That's looking good. Yeah, so they're continuing to build. I should say the speed of this isn't this. I've deliberately slowed this down a little bit so I don't set fire to my laptop back there that's dealing with all of this, and also so it fits with the timing. The speed that these are being deployed is not limited by FlowForge. So the data that comes, actually, I'll just put these side by side for a minute. So the data that comes from the PLC devices out of here then comes into here. So that's the project out and project in. And as I say, wherever this is running, the data will flow through. So we're now looking at the flows which are running on our central management system. This is the Node-RED instance that's providing the interface where we're monitoring the deployment happening. So basically, as I was saying, this is so all of those PLCs, as they're coming online and collecting data, are sending the data in here. This then writes that data to a local database. So I'm using SQLite for the sake of this demonstration. Adds additional useful information like what point in time does this information come in. It also works out when the first time that particular PLC was seen. So it does various things it needs to, and then just writes it into a database. So that's what that top section does. The next section, and we'll demonstrate this in a bit, but this deals with monitoring when devices go offline. So when a PLC goes offline, so we will show, I will manually, deliberately take some offline, and this will show a list of those devices that have gone offline, as well as showing a pop-up on the dashboard that I've shared with everyone, showing those devices have gone offline. So the idea of this would be factory floor engineers who quickly want to be able to get alerts, understand which machine or PLC potentially has a problem so they can quickly respond to that. This could be something that's delivered via HMI screens around the factory floor. It could be on personal devices. I've even seen examples where this sort of logic pushes something out over a tannoy system. So it uses text to speech to actually announce which machine's gone offline. So that's what that section deals with. The next section is basically generating this graph. Oh, look, we're up to 50. That's great. Everything works. Yay. So this section is actually creating that graph. So it's monitoring all the PLCs that are live, which version of the software they're currently running, and then creating that graph. The next bit is doing the CPU and RAM data. So this is outputting these two graphs. Let's just talk a little bit about these. So what I've done is limited it so it only shows the current top 3 PLCs for CPU and RAM usage. The reason I did that is when I first graphed 50 PLCs, it just became a complete mess. You couldn't read it. So what this hopefully allows an engineer to do is quickly look and go, okay, so which device is it? What's that one that's just gone up to? I mean, it's still a tiny amount of RAM it's using, but is that something I need to look at? Is something going wrong with that? Same with the CPU. So it's just showing the top 3 devices and then a little bit of history. I think it shows like a minute of history of other devices that have been up there. And the last thing is, so this is more about, so because I'm doing this as a presentation rather than a production system, this allows me to clear down all the graphs. So if I now wanted to delete all the PLCs I've just created, I can use this button here and it will clear everything back down. So I could run this over again. So that's what that section is down there. Okay, so that's covered the flows. Perfect timing, is that we can see we're now up to 50 instances, which is great. 50 PLCs. I'll try and keep using the word PLC. I apologize for keep calling them instances. So let's have a look at what we can do with FlowForge's tools. Now we've got these 50 PLCs running, they're sending back data. But what can FlowForge help us do? The first thing FlowForge can help us do is to change part of a flow which is running on one of those devices. So I'll open up FlowForge. So I'm going to go. So this is now the FlowForge team, which is, so we've got the webinar IoT, so that's the software running on the PLC devices, and then webinar man, that's the management interface and dashboard. So I'm going to go into webinar IoT. I'm then going to go into devices. So we can now see these are the 50 devices that I've just created. So we can see various useful information when they were last seen, current status, current snapshot. So, but what if we want to change some of the, like, what if we want to change the flow that's running on these? So I'm going to click on the first one. I just have to move that out of the way. So I'm going to put this device into developer mode. What that means is I've now separated this individual device from all of the rest of the devices that are working together and running the same code. This now allows me to change the code or flow, which is running on this PLC, but it also means that if there was another engineer at the same time making changes, their changes won't impact this device. So I've basically said, keep the code as it's currently running on this device, keep the flow as it's currently running on this PLC, and whatever happens, don't change it. But I want to change it. So next thing I'm going to do is enable remote access. So this has created a connection between FlowForge and the device. In this case, the device, which has been simulated just over here, but it works just as well to the other side of the world. I'm going to open up the device editor, and hopefully this is going to now load the Node-RED interface of that particular PLC. So this is the same flow that I showed everyone a few minutes ago, but this is now one of the instances which is actually running and sending information through to the dashboard that I've shared. So all I'm actually going to change is the version we're running, but I found a bug. I think I've got a fix for it. So I've changed the flow, and I'm going to change this over. So this is now running version 1.1. Oh, actually, I'll just do 2.1 because it's just 2.0 because it's easier to see. I'm now going to deploy this. What we should see in a moment, after a dramatic pause, is that the version 2 should now appear on the top graph. So we can see that's now dipped down. So we now only have 49 devices running version 1. And we can see we now have one running version 2. So I can now leave that PLC in that state for as long as I want. If I might want to leave it for a while to check if my new version of the flow works really well, whatever it might be, I can leave it like that, and that's absolutely fine. Let's say now I come to a point later where I feel that build is fine and I want to deploy it to the rest of the devices. So let's have a look at how to do that. So I come back onto, this is the device where I edited it. So what I'm going to do is I'm going to create a snapshot. So a snapshot is, hopefully somewhat self-explanatory, but it captures that flow, all of its settings, all of its configurations as it was at a moment in time. So I'm going to create a snapshot. I'm going to call this 2.0 because that's in line with what I put in the flow. I'm going to set as target. What set as target is doing is saying all of the other PLCs, which are grouped together with this one that I'm working on here, all of them will get this new version deployed to them. So I'm going to set as target 2.0 and press create. So this takes a little bit of time in comparison to just changing over one device. So we can see now it's all of these devices are now being brought down so they can be updated to version 2. And then what we will see after I pad a little bit, it just take a little while, is we will see version 2 of the build start to come back online. What we're also now seeing in that top right-hand corner is this system. So I mentioned as one part of the flows had an alerting system that could tell engineers if there was a problem with a PLC or a machine. So what this has started to do is pick that up. So right now it's saying 49 devices are offline. It's only 49 because one of them already had the relevant version 2 build on it, the one that I edited. So that's just going to remain there. But the rest have gone offline. Now, normally, if I was building an alerting system, I wouldn't have it alert as aggressively as this, but so normally, I don't know what everyone else does, but you'd probably say, monitor a system. If it fails 3 times in a row over so many seconds or minutes, generate an alert. But for this, I just made it so the first time it failed, it generates alert just so people could see that. If I want to know which devices they are, what everyone should now be able to see if you're looking on the dashboard is they're just disappearing now because everything's coming back online. But it shows down here. So this IoT 1904 PLC has been offline now for 97 seconds, gives you that information to hopefully, know. So I hope everyone can still hear me okay, because my fire alarm's just going. 1 second.
Yeah, you're good. You're good, Rob.
Oh, it's fine. It's not, I assure you, it's not a real fire alarm. The people are working in the building. So
we can't hear it. We can't hear it.
You can't hear me, or you?
No, we cannot hear the fire alarm.
Brilliant. That's fantastic. Only the second time it's gone off today. Not inconvenient at all. So what we then saw actually is that whilst I was talking through that, all of the devices have come back online, so we can no longer see them down here. And what we can see up on this line here is that we now can see that 50 devices are running version 2 of the software. So that's taken us through a very common task of testing a new version here. So moving one PLC over to a new build. Once we're happy with it, we've deployed that to all the other devices. We've received some alerts in the meantime, which I would make less aggressive for production usage. And then we can see all the other devices are back online. Another thing I'll demonstrate, just so we can see these alerts a little bit more that appeared down at the bottom, is I'm now going to just deliberately break a few of the PLCs, which I can do from here. So what I'm just going to do is select 2 of the PLCs and stop them running. So what we should hope to see now is we'll get an idea of how long the delay is. It's pretty quickly that they show up on here. Yeah, as I say, perhaps more quickly than you would want them to be. So we can see there. You should now be able to see if you're looking at your own dashboard or looking at on my screen, that's now dropped down. So we're now down to 48 devices are running version 2. In a moment, it will, after a dramatic pause, which I will continue to fill by talking, it's going to come up, I assure you. Down here, it's actually going to list out the devices, which we saw previously. There we go. So it's come up with those devices. It gave us an alert up in the top corner. And yeah, as I was saying before, that's just really pertinent information for engineers on factory floors to go and resolve the issue. So I will just break a few more. Let's break 4 more. Okay, so we should see those drop offline. And it's potentially possible. I mean, here we've just got 2 builds at the same time, but you could potentially have a few different builds running on devices within this group of PLCs at the same time. So it's not just the case that it would have to be 2. But yeah, we can see that's now dropped down. We will start getting more alerts saying that there are more devices offline. I think I will just bring that back up. So I'll start those back up. And they should appear in a second. And that covers everything that I wanted to demonstrate today. I have a feeling, I'm hopeful that this will there'll be some, I've not been watching the chat or the Q&A pod, but hopefully there's some questions on this, and hopefully also there'll be some more. I feel that hopefully this is giving you a really good idea of how easy it is with FlowForge to manage. I mean, in this case, it's 50 devices. If we had longer, I've tested this with much higher quantities of devices or PLCs. So yeah, but it's really easy with FlowForge to manage connecting to your devices, create new builds, and get it deployed out to your PLCs.
And great. Thanks, Rob. Yeah, great. So, Rob, could you bring that back up the FlowForge device list?
Of course, yeah.
Because I just want to make sure people are kind of aware that you can also add new devices in to this scenario, right? So there is a kind of an add device button. So because kind of Rob onboarded 50 at a time, but often people need to onboard kind of individual devices throughout the life cycle, right? So you can kind of certainly go and add more. And you can also see the status of the devices from here too, right?
Yeah, and I suppose, yeah, it's a good point that, so when I onboarded those devices, I used a single token, which you can create in FlowForge to onboard them in mass, but you can also create individual tokens for individual devices. So depending on what your workflow is, yeah, you can do it either way. And as Ian said, you can do them, yeah, one at a time. And we can see the updates on all our devices, including showing us which one is still in developer mode. The one that I was working on, we can see on the side there.
Right. Okay, let's turn to some questions. The first question is, what kind of images are used to simulate the PLCs? By PLC, do you mean a machine which actually runs Node-RED? In many cases, the machine running Node-RED is different from the PLC.
Okay, so we're using FlowForge's own Docker build of its device agent. So it's all open source. If you want to take a look at it, it says based on a Linux distribution called Alpine, which is very lightweight. Yes, so this is running. So the assumption in this demo, or the scenario in this demo, is that we're running Node-RED on the PLC. Now, if you, and I'm sure a lot of you have PLCs where that's not an option, you would be running it on a device next to that PLC or in close proximity where it can access the sensors or the data from the PLC. So yeah, so we're using our own build of the device agent, which is based on Alpine Linux, which once that's installed, it then can communicate with FlowForge and manage your Node-RED instances.
Yeah, and kind of the PLC also has to be able to run Node-RED too, right? To have that running on the PLC. And so certainly some PLCs aren't able, but a lot more of the modern PLCs absolutely can run Node-RED natively. Next question is, does FlowForge manage this kind of migration as far as the 50 PLCs, or is it individual packages? So FlowForge packages gather it in the cloud. I think so. Actually, I'm gonna go see. So, Rob, do you have anything to? I'm gonna go see if I can go find the person who answered this to kind of clarify that question. But I think that kind of. Go ahead, Rob.
No, I was going to say I'm not entirely. Yeah, perhaps if the person who's asked the question could. And
yeah. So Toby, I opened up your mic, so you can actually come in if you'd like to ask a follow-up question for that. Yeah, you have to unmute your mic too. Okay, maybe Toby's either shy or not here. So okay, then let's
No, I'm here.
Okay.
I think you guys answered it because you mentioned that it's within the FlowForge application, and you said that you put a wrapper around it. So, and that wrapper is talking to the individual Node-RED deployments on the edge devices, correct?
Yeah, exactly that. Yeah, so in this case, we're using our Docker device agent, although there is one you can install directly onto a device, say such as a Pi or something like that. And once that's installed, it then puts Node-RED in place, and also adds the control around that, so FlowForge can then manage that device from that point onwards.
So like it's perfect like with Octave 22 or Control X as far as Bosch's product or whatever, because it'll just update your local Node-RED to whatever program changes, and you can touch 50 at a time if you had to.
Yeah, exactly. Yeah, and also if you need to update Node-RED itself, you can also manage that in the same way. Yeah, so yeah, it makes it a lot easier.
Definitely better than going out and touching 50 individually. But in this way, I believe you answered it when you said that FlowForge has a wrapper around it. So that's part of you guys's, what do you call it? Like application properties from the cloud that you can initiate this from your software.
Yeah. Once I brought up the example devices, the 50 devices, they were then associated with this FlowForge team that I'm currently looking at. And once that's done, subject to hardware failure, you shouldn't ever have to touch that PLC, or, if it's, the device that's running near the PLC, if the PLC itself can't support Node-RED, you shouldn't ever have to touch it again. Anything that you should need to do, you should be able to do via FlowForge, either to an individual device where appropriate, if you want to do some testing, or en masse where you're happy, you're ready to roll something out.
Okay,
Awesome.
perfect. Thanks, Toby.
Thanks.
So I'm going to move on to the next question from Adele. Is if you're using an OPC UA server with authentication, username, password, and you have 3 servers with the same configuration, does a snapshot deploy the changes with the authentication service?
I'll have a go at that in general terms.
Yeah.
I can't answer specifically on that on OPC UA. So same configuration, does the snapshot deploy the changes with the authentication service? So anything which is associated with the Node-RED instance, which if then deployed to a device will be, so you have environment variables which are device specific, and I use some of those in the demo, like say the device has its own name, but you can have other environment variables that will just be brought in from the snapshot that you have created, wherever you've created it. So hopefully, yeah, that kind of answers that question. I can see Ian's opened up the mic if you want to.
Yeah, Adele, if you have a follow-up question, feel free to unmute your mic.
Yeah, no, I was just asking because normally you could have the OPC UA server with or without authentication. So I know when you are using the OPC UA node, you have to configure that appropriately. So I was just wondering if once you configure that on one flow, do the snapshot and then deploy to other Node-RED instances that are also running OPC UA, if that information goes with it, or you will have to go into the node and enter it again, basically.
So there are various ways that will make it so you don't have to. So the goal is you would never have to go back to the device, because at that point, that just creates loads of problems. The device might not even be in the same building as the engineer. So there are various different solutions. I've seen that being addressed by using environment variables. I've seen it where, there was a configuration file that I used to deploy all of those 50 examples. And I've seen where customers have added extra configuration into that file. So there's a file that you push out to all of your devices when you first switch on the FlowForge device agent. So potentially you could put credentials in there. I don't want to say what's the right solution for a particular scenario, because the sort of cop-out answer is it depends. But there are at least 2 ways that I'm aware of to push out credentials. And I wonder though, perhaps are you questioning about where it's something that's configured directly within the instance, so not something that you can load in programmatically, perhaps, is the question. I don't know if you am I understanding?
Something you configure manually, but then you need to update, like if you push an update that's already configured.
Yeah, I believe it works. I've seen it work in scenarios I've used on this demo today. I'm just a little bit reticent to say it works in all scenarios. So I believe it does work. For instance, I used that sort of configuration for the way that we were using MQTT. I didn't need to go and reconfigure that on each. So I believe it works. I'm 90% confident. Sorry, I can't do better than that right now. I hope that's still useful though.
Okay, so let's great. Thanks, Adele, for the question. So we'll move on to the next question. Is the remote access to device in developer mode also available in the open source self-hosted version of FlowForge? I actually don't know the answer to that. So do you go?
So it is, but I guess I'm reading between the lines. I think you're probably asking about, is it available in the free version, perhaps?
It's the open source version.
Yeah. So I mean, perhaps it's so no, the remote controller devices is only available for the paid version of FlowForge, whether you run that on either use FlowForge Cloud, which is our own hosted version, or whether you're hosting it yourselves.
Okay. All right, next question. Did all the devices update to the same snapshot automatically because they're all under the same instance? Or how can they deploy snapshots to certain devices but not others?
Yeah, you absolutely nailed why it worked. Yes. So what I could have done is I could have had 4 different instances with groups of PLCs associated with each one of them. And then I could have been, so in this example, I'm assuming you have all identical and all output the same information. So therefore the same flow will work. I know in the real world, that's probably not the way it's going to be. So yes, you can associate groups of devices with instances. Another thing that we're working on, we're not quite there with it yet, I think it might be in the next release or perhaps the release after that, is being able to manage those changes through a DevOps pipeline as well. So you could have a group of on-site devices, which are your testing devices, and then a group which are production. So you can then work on a flow, change it, push that through to a group of devices, which are your testing devices, check that's all okay, and then with one more click, then push that out to the full set of those devices. So we're working on ways to segment those to make that flow easier.
Okay, great. Next question. Nice demo. Is it possible to share the flows so we can play and test it?
Absolutely. They will be, I think probably the easiest way, we'll link to them for the comments on the YouTube, probably the easiest way, Ian. Yeah, if that's, so yes, yeah, absolutely. The only thing so everything I've shown other than, so the system which builds all of the instances is something that I won't share because you need to set up a lot to make it work, but the actual flows we're using on FlowForge, I will share those so you can import them and take a look.
Okay, great. Can we batch update multiple devices flows without touching their configuration nodes? I think that might be kind of back to the OPC UA kind of type of discussion.
Without touching their configuration nodes. Yeah, I mean, yeah, I suppose I'm trying to, understand the inference of touching in sort of air quotes. Well, they're not air quotes, just quotes.
So let me try and get Bertie available in here to ask for a follow-up question. Bertie, are you kind of, if you unmute yourself, could you kind of do a clarification for us here so we can better answer your question?
Sure. Yeah, I think it goes back to the OPC UA topic. So some nodes have an IP address hard-coded into their configuration node. So I go into the flow, I connect to this specific PLC or OPC UA node. There are multiple of those. And if I change something on, let's say, the main device, and I want to apply the changes to many sub-devices, which all use the same configuration, but just with a different IP address. Can I do that? Can I just, let's say I moved one debug node by 1 pixel, and I can just apply that change to all the sub-devices, all Node-RED instance.
So yes, the only thing is, as I was saying, I can't speak specifically to the custom node you're talking about, but in general terms, so certainly a lot of the nodes that I use, you can set the configuration of, pass it in from environment variables, from a global scope or from the flow. So you can pass in either, where you want it to be different on a device by device basis, or where you say are just talking to one API somewhere, and you want, even though you're changing something other than that relates to that custom node, you want it to continue to connect to the same API. So I've definitely seen this work. I'm just, as I say, just because I've not used the particular custom node that you guys are talking about, I apologize. I just can't speak in specifics to that. I'm sure there's a good solution.
So we would go the route with environment variables, for example. I know that it's also possible. Thank you.
Yeah, great. You're welcome. Thank you.
All right. Continuing on to the next question. How does the license model work? Is there a self-hosted air gap version? How the SLA and patch management works? let me take this one, Rob, just
Sure.
to give you a chance to
Thank
get a
you.
drink of water. So,
Thank you.
FlowForge is we have a managed service called FlowForge Cloud, where you can basically get a subscription to it and roll out the devices using device management with FlowForge Cloud, and we run FlowForge for you, right? It's not air gapped; it's basically available over the internet. We do allow you to do self-hosted, self-managed, where you can absolutely air gap it and put it within a factory to do that, right? So we offer both. Depending on the level of subscription you get, we offer different SLAs, and patch management is kind of certainly we typically have a release every 4 weeks. Certainly security and critical patches we roll out as soon as possible. So Ardil, I hope that answers your question. Let me I'll actually kind of find you, and if you have any follow-ups, you can unmute your mic. If not, we'll move on.
Yeah, hi. It was actually a wonderful demo from your side. Thank you for it. We just want to know, like in our factories and most of the locations, it's an air gapped one. So
Yeah.
just one follow up. But you answered it quickly. I think it's fine.
Okay.
I just want to know the terms and conditions in the SLA. It's listed out on the website. I can see it, or I can...
Yeah, and we can certainly have someone contact you kind of to talk more in details about that too.
Yeah.
Okay.
Perfect. Yeah. Thank you.
All right. Thank you. So next question. I have around 75 devices running Raspberry Pi where I've asked last year for the use of the editor directly on device debugging flows. Now it's available, but only as a premium version. Will there be a possibility for single premium features at some point? Is running FlowForge local install? FlowForge local install. Do you want to take this one, Rob? Or
Yeah, sure. Well, I think probably both of us probably have some insights on it.
Sure.
So I don't know as to, which features we are planning. So I'm taking it from this that you're not using FlowForge Cloud. Yeah, he's running on FlowForge local install. Yeah. So I think we're always looking at what features, we're all quite strong advocates for open source, and we are always looking at the features that we're adding to our premium version alongside the fully open source free to use version, and trying to get the balance right. We need to a certain extent make some money, because that helps us continue to generate, work on both the paid for and the open source version. I think we're always happy to take feedback. I have seen feedback about features that people would like to see through, let's call them more affordable options, people feeding back on our GitHub about that. So that's one way you can, vote saying, hey, I feel like this thing shouldn't be behind premium. Ian, is there anything that you want to...
No.
Is that...
No,
yeah.
I think you covered it. So I've actually allowed you to talk. If you want to do a follow-up, you're more than welcome. Okay, we'll move on. I had good experience with Node in the past, but when I tried loading large time series data files in Node-RED, and it crashed multiple times. What about reading and processing large files in FlowForge? Will it scale? Not really about device management, but we're happy to answer Node-RED and FlowForge questions too. So
So will it scale? The short answer is yes. You definitely can, with thought and planning, build very complex applications running in Node-RED that deal with a lot of data. The problem that I often see is an application will ingest a lot of data simultaneously, and then start to process it. So you pull in all the data, which takes up a lot of RAM, or a lot of storage space, and that can potentially cause problems with Node and Node-RED. So one good thing to try and do is to process little bits of data at the same time. You were mentioning a time series database. So that's great, because that hopefully gives you the opportunity to process bite-sized chunks of data at a time, do what you need to, pass them on to the next step, rather than pulling on all in simultaneously. The flip side of that is sometimes I see where flows are having to pull in, let's say, a CSV, which is literally 2 gigabytes of data in a CSV. And it's very hard to process that data in any programming environment without accessing a lot of data simultaneously. I have seen some custom nodes that allow you to follow a file, which potentially might allow you to read parts of that large file at the same time. But absolutely, I have still not seen anything that one of our customers is trying to do with Node-RED, or some of the challenges that people talk about in the more general Node-RED community outside of FlowForge, that there isn't a solution to. It just requires trying to minimize how much information is being stored in your application at any given moment in time.
All right, so we've got 2 last questions, and hopefully we'll get to them before in the last 3 minutes. So the next one is, are there plans to expand FlowForge to be used as a standalone Linux image on a Raspberry Pi, which is also able to update the system image itself, not only Node-RED? Let me answer that. So I think right now the device management is really focused on Node-RED, and I kind of certainly, people have suggested this in the past. It's something we're not ready to take on in the near future, right? But long term, sure. But right now we're very, very much focused on Node-RED. So yeah. Rob, do you have anything to answer?
Yeah, I was just going to say, we're trying to deliver the most value by automating all the bits which are a common problem. When you start talking about, yes, if everyone had a particular Pi model, then it would be quite easy to do the image. But the reality is, what we see from our customers is everybody's using slightly different environments to host the device agent, and therefore Node-RED. So it's not a focus for us at this time.
Yeah. Okay, so we'll take kind of this last question. So I have a more general question about scenario he's seen at customers. Is it more like this scenario where the PLCs have Node-RED integrated, or are there local PCs connected to the PLC? Or are multiple instances in the main server, on-prem or on the cloud, communicating with dumb PLCs, dumb by mean kind of unable to run no software, or another scenario?
Yeah.
I'm going to take this one first.
Yeah, please do. Yeah,
I think we see everything, and we think, I think, right. So I think, I think that's the challenge with manufacturing. It's so heterogeneous, so that everyone's setup is different, quite frankly, right? I can say that I think more and more the PLC vendors, their new generation hardware is becoming sophisticated enough to run something like Node-RED directly, right? So, and people are taking advantage of it. Someone mentioned Opto22 as an example of that they've been, their group, Epic and Rio, run Node-RED directly. But a lot of the older PLCs, they just don't have the software infrastructure or the compute facility to be able to run something like that. Right. So I think it depends on the scenario. And we've certainly seen kind of a lot of different setups there. So
yeah. All
right. So I think we're done. Someone just mentioned in the chat that they just received the first Epic group Epic. So it's they're a great piece of hardware. So all right. Well, thank you, Rob. It was great. Great to have this, and thank you everyone for the feedback. At the end, we've got a quick survey, so please kind of give us feedback on the webinar. There's Rob, do you want to put your screen back up? There's some other links that we wanted to point people at.
If my brain can work out how to do that, yes, I got there in the end.
Okay. So there's a Influx data webinar that Rob did about basically kind of bringing data and storing it into an Influx database. That's been very good. Richard Meyer, who's a new developer advocate, has been doing a series of articles on OPC UA. So kind of certainly check those out too. like I said, we'll in the email we send, follow-up email, we'll include links to these things too. All right. All right. So thank you, Rob, and thank you for everyone for joining. Have a great rest of the day. Take care.
Thanks, everyone.